action.
Trust me, he's good at this game.
I have this game called Roll Up, and we use it to collect some data today.
Still practicing. Oh, no.
Ty, how'd you do, dude?
Just be safe, because you only gotta get up to the third spot.
Yeah.
Here's the question. Take a second to read it over. Let's go ahead and start by checking conditions. Looks like we're given that we have a random sample. We have 56 females, which is less than 10% of females, and 39 males, which is less than 10% of males. Sample was selected randomly, so we can assume that the groups are independent. N, P hat, and Q hat for both groups greater than or equal to 10. Looks like conditions are met. We're going to use a normal model to construct a 2-prop Z interval for the difference of two proportions. Our observed proportion of females that were able to score over 500 points or more was 0.214, 12 over 56. And our observed proportion of males that were able to score 500 or higher was 11 over 39, 0.282, giving us an observed difference of 0.068. Now we're going to use our calculator to find a 95% confidence interval for the difference in proportions of males and females that can score 500 points or more in the roll-up game. So we're going to press Stat, page over to Test, page down to 2-prop Z interval. In X1, we're going to put 12 females successfully 500 or higher out of 56, and X2, 11 males out of 39. We want a 95% confidence interval. Hit calculate, and it looks like our interval is from negative 0.2452 to positive 0.1097. Now we can go ahead and interpret the interval. We can be 95% confident that between 24.5% fewer to 11% more females can score 500 points or higher in the roll-up game than males. Looking at part B, does your confidence interval support a position of no difference? Our confidence interval does support a position of no difference. The difference of 0 is in our confidence interval. It goes from a negative value to a positive value, including 0. This would support a position of no difference.